Have you ever stopped to think about how your laptop or smartphone can connect to the internet without being physically plugged into a router? And how this technology has become so ubiquitous that we now take it for granted, expecting a seamless and constant stream of data wherever we go. This is all thanks to Wi-Fi, a technology that has revolutionized the way we access information and communicate with each other. And understanding how it works is crucial in today's world, where wireless connectivity is no longer a luxury, but a necessity. As someone who uses Wi-Fi every day, you might be curious about the underlying mechanics that make it possible. And by the end of this explanation, you'll have a deeper appreciation for the complex processes that occur behind the scenes to keep you connected. So let's dive into the core explanation of how Wi-Fi works, starting with the basics. Wi-Fi is a type of wireless networking technology that uses radio waves to transmit data between devices, and it operates on a specific frequency band, typically 2.4 gigahertz or 5 gigahertz. When you connect to a Wi-Fi network, your device is essentially tuning into a specific radio station, and the router, which is the central hub of the network, is broadcasting its signal on that station. The router receives data from the internet and converts it into a radio signal, which is then transmitted to your device, allowing you to access the internet, send emails, and stream your favorite shows. But how does the router know where to send the data, and how does your device know how to receive it? This is where the concept of IP addresses comes in, which are unique identifiers assigned to each device on a network, allowing data to be routed to the correct destination. Think of IP addresses like street addresses, where each house has a unique address that allows mail to be delivered to the right location. When you request data from a website, your device sends a request to the router, which then forwards it to the destination server, and the server responds by sending the requested data back to the router, which then transmits it to your device. Now, let's talk about the actual process of transmitting data over Wi-Fi, which involves a technique called modulation. Modulation is the process of modifying the radio wave to encode the data onto it, and it's similar to how a radio station modulates its signal to encode music or voice onto the radio wave. The router uses a specific modulation scheme, such as quadrature amplitude modulation or QAM, to encode the data onto the radio wave, and your device uses the same scheme to decode the data from the radio wave. This process happens incredibly fast, with data being transmitted at speeds of up to several hundred megabits per second. One of the key concepts that makes Wi-Fi work is the idea of frequency hopping, which allows multiple devices to share the same frequency band without interfering with each other. Frequency hopping involves rapidly switching between different frequencies or channels to minimize interference and allow multiple devices to transmit data simultaneously. This is similar to how a walkie-talkie works, where you need to tune into a specific channel to communicate with someone else, and if someone else is using the same channel, you'll experience interference. Wi-Fi routers use a technique called spread spectrum to minimize interference, which involves spreading the data across multiple frequencies, making it more resistant to interference. There are, however, some trade-offs to using Wi-Fi, such as security risks and interference from other devices. When you connect to a public Wi-Fi network, you're essentially broadcasting your data to anyone within range, making it vulnerable to interception. This is why it's essential to use encryption, such as WPA2, to secure your data, and why public Wi-Fi networks often provide a warning about the risks of using them. Additionally, Wi-Fi signals can be disrupted by other devices, such as microwaves or cordless phones, which can cause interference and slow down your connection. Despite these limitations, Wi-Fi has become an essential part of our daily lives, and it's used in a wide range of devices, from smartphones to laptops to smart home devices. In recent years, we've seen the emergence of new Wi-Fi technologies, such as Wi-Fi 6, which promises faster speeds and better performance in crowded environments. We've also seen the development of new devices such as mesh routers, which use multiple access points to provide a stronger and more reliable signal throughout your home. In everyday tech, Wi-Fi is used in a variety of ways, from streaming video to online gaming, and it's become an essential part of many devices, including smart TVs and gaming consoles. For example, when you stream a video on your smart TV, it's using Wi-Fi to connect to the internet and receive the video signal, and when you play online games, your console is using Wi-Fi to connect to the game server and communicate with other players. Wi-Fi is also used in many smart home devices, such as thermostats and security cameras, which use Wi-Fi to connect to the internet and send data to the cloud. In conclusion, Wi-Fi is a complex technology that relies on a combination of radio waves, modulation, and frequency hopping to transmit data between devices, and understanding how it works can help you appreciate the engineering that goes into creating and maintaining wireless networks. The next time you connect to a Wi-Fi network, remember the intricate process that occurs behind the scenes to keep you connected. And if you're curious about more topics like this, be sure to keep watching our channel for in-depth explanations of the latest technologies.